Hello everyone, welcome to this video. In this video, we'll be looking at another question from IIT-JAM Mathematical Statistics paper 2021. This is a 2-mark question and it is a MCQ type of question. So only one option would be correct. So here you are given some system of linear equations, right? Where what is A? A is given to be some real number. So that means for that real number we have this equation, the set of linear equations here, that is ax plus ay is equal to a plus 2, x plus ay plus a minus 1 z is equal to a minus 4, ax plus ay plus a minus 2 z is equal to minus 8, and we are given three unknowns x, y and z. Then they are asking which of the following statement is true. So here you are given the four options. The first option says when a is equal to 1 you have a unique solution, and then the second statement says when a is equal to 2 you have infinitely many solutions. Then a minus 2, for a minus 2 you are given for option C unique solution, for option D infinitely many solutions. So what we can do, we can convert first of all our given system into the corresponding echelon form. So let's write down that system. So for the solution, your system reduces to our system of linear equations. Our system of linear equations reduces to the following form, right? What is that? So let me write down. For the unknowns it is a, and for the z it is 0, and the coefficient matrix that is given to be a plus 2. So basically what we are doing, we are writing the coefficients here, right, and the right hand side that is written over here after the colon, right? So the next term is then 1 a minus 1 and a minus 4, 1 a minus 1 and a minus 4, 1 a minus 1 and a minus 4, and the last one is a minus 2 minus 8. So it is a minus 2 and then minus 8. So this is the given system, right? And we have written it to be in the matrix form, where this one corresponds to your matrix A, the coefficient matrix, and whole of this corresponds to the augmented matrix A colon B. This is the matrix A, right? So after writing it, now we want to convert this system into the corresponding echelon form. We want to convert the system into echelon form. Now you can do it two way. One thing you could do it algebraically, where you can just take a to be as such and do the calculation in terms of a. Another method is, for the given values of a, we could try out these solutions, right? Firstly we could substitute a is equal to 1, then a is equal to 2, then a is equal to minus 2. So let's see. So let's proceed. When we have a is equal to 1, let's see, do we achieve a unique solution in that case? So the calculation would be easy when we substitute the values here. So instead of writing a, now we are writing 1. So it is 1 1 0 and it is 3. Then you have 1 1 1 minus 1 is 0. Then you have 1 minus 4 is minus 3. Then you have 1 1 1 minus 2 is minus 1, and then minus 8, right? So this is the given matrix. For this given matrix here, we wanted to convert it into the corresponding echelon form. So we'll apply the row operation on R2, we'll apply the operation R2 minus R1, and on R3 we'll apply the operation R3 minus R1, right? Simple as that. So let's apply those operations. So the first row would be as such 1 1 0 and 3, right? For the second row it is 1 minus 1 0, 1 minus 1 0, 0 minus 1 0 minus 0 0, minus 3 is minus 6. And for the third row it is 1 minus 1 0, 1 minus 1 0, minus 1 minus 0 is minus 1, and then minus 8 minus 3 is minus 11. So this is the matrix after applying those row operation. Now you could see, and this is not exactly in the echelon form, but you could see here we have 1 0 row. So that means from here we could estimate the rank of the matrix A. So from here you could say that the rank of matrix A is surely less than 3, as we have 2 non-zero rows, right? So obviously the rank is either 2 or the rank is either 1. So in this case the rank of A is less than 3, which is the number of unknowns, right? And basically for unique solution, what do you require? You know already the result, that for unique solution we require the rank of A to be equal to the rank of A augmented B, and both of them should be equal to 3. But in this case this thing is less than 3, so we do not have a unique solution. So in this case no unique solution is there. So that means option number A is incorrect here, right? Okay, so that means we can now go for checking A is equal to 2. So let's check that A is equal to 2. We just have to substitute A is equal to 2 in this given matrix. So when we substitute in second case, when A is equal to 2 plus 2, so in this case your matrix would reduce to this matrix: 2 2 0, and then you have 4, then you would have 1 2 1 and minus 2, then it is 2 2 0 and minus 8. You could check this matrix, right? So this is your matrix. Now we wanted to convert this given matrix into the corresponding echelon form. So what we wanted to do? We wanted to achieve 1 here. So we wanted to make 1 here. So in order to make 1 here, what do? We apply the row operation on R1. We'll apply the operation that R1 divided by the number 2. So finally you have the first row would become 1 1 0 and 2, and the second and third row would be as such. So it is 2 2 0 and minus 8, right? And then it is next we wanted to make the this element and this element, both of them as equal to 0, right? We wanted to make both of them as equal to 0. So here we have to apply another row operations. On R2 we can apply the operation R2 minus R1, and on R3 we could apply the operation R3 minus 2 times of R1. So in both the cases we have to use the first row only. So the first row in this case would be as such. So let's just copy it down. For the second row it is 1 minus 1, that is 0, 2 minus 1 is 1, 1 minus 0 is 1, minus 2 is minus 4, right? And then you have 2 minus 2, that is 0, then you have 2 minus 2, that is 0, 0 minus 0 is 0, and then you have minus 8 minus 4, minus 8 and minus 8 and minus 4, minus 12. So this is what you have after calculation, right? So here you could clearly see what is the rank of matrix A. The rank of matrix A is 2 because we have 2 non-zero rows, and the rank of the matrix A augmented B, that is equal to 3. So clearly in this case both the ranks, they are not equal. So rank of A is not equal to the rank of A augmented B, and so this is the condition for no solution. So that means whenever we have A is equal to 2, we have no solution. So in this case, in the option B, they have given to you that you would obtain infinitely many solution when A is equal to 2. So this option is also incorrect. Now we have to just check for A is equal to minus 2 in order to see for both of these questions, right? And moreover, in the exam, what you can do, instead of starting from option B, you could just start with a is equal to -2, and because solving one thing would simply give you either correct or incorrect option for option C and D. That means in one calculation you could just cross out two options, right? So and maybe if you are lucky, you could get the final solution when you solve for a is equal to -2. Why? Because, and if that is so, in that case you would not be required to do further calculations for a is equal to 2 and a is equal to 1, right? So okay, now next let us solve for a is equal to, so when a is equal to -2, your matrix would reduce to the matrix -2, -2, 0 and 0. Then you have 1, -2, -3, and then you have -6. Then you have -2, -2, -4, and you have -8. So this is your given matrix. Now we wanted to make this element as 1. So how we could do that? We could apply the operation that we can exchange row 1 with row 2, because here in row 2 we have the element as 1. So it is equal to, in place of row 1 we could write row 2, that is 1, -2, -3 and -6, and in place of row 2 we could write row 1, that is -2, -2, 0 and 0, and the third row would be unchanged, so it is like this only, right? Now next we wanted to make this element and this element, both of them as equal to 0. So how we can do that? On R2 we could apply the operation that R2 plus 2 times of R1, and on R3 we could apply the operation that R3 plus 2 times of R1. So your matrix, the first row would be as such, so it is 1, -2, -3 and -6. For the second row it is now equal to -2 plus 2, that is 0. Then you have -2 plus -2 -4, that is -6, right? Then you have 0 -6, that is -6, and then you have 0 -12, that is -12. For the third row it is -2 plus 2, that is 0, -2 -4, that is -6, then it is -4 -6, that is -10, and finally it is -8 -12, that is -20, right? Then we wanted to make this element as 1. So how we can do that? We have to apply the operation that on R2 we will divide this by -6. So when you divide this by -6, so let's copy down the other two rows, 1, -2, -3 and -6 as such. The third row is also as such, 0, -6, -10 and -20, and the second row is 0 divided by -6 is 0, then 1, it is 2, right? So this is your matrix after calculation. Now once we have made this element as 1, we wanted to make this element now as equal to 0. So how we can make this element as 0? We can apply the row operation on the third row, that is on R3 we could apply the operation that R3 plus 6 R2, right? Because we wanted to make this as this element as equal to 0, and we can use row 2 for that. So that means your first and the second row would be as such in this case. So it is 0, 1, 1 and 2, and in the third row it is 0 plus 6 times 0 is 0, it is also 0, -10 and plus 6, that is -4, -20 plus 12, that is -8. So this is your matrix. So here you could see the rank of matrix A is equal to the rank of matrix A augmented B, and both of them are equal to 3, which is the number of unknowns which is given to you for the given system of linear equations. So that means when A is equal to -2, we have a unique solution. We have a unique solution with us. So once you have the unique solution, you could just mark your answer here. So let's see, when a is equal to -2, we have a unique solution. So that means option C here is the correct option. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.